Okay. Fine. So, welcome back. So, guys, welcome back to our freshman session, credit risk modeling. And we were talking about developing CCAR models, right? So, we were talking about applications of a linear regression model into a CCAR framework. And one thing that we observed in the last class was we saw that, how is it that the the CCAR results are kind of interpreted, right? So how is it that the linear regression results are to be interpreted, and what implication does this model have for the CCAR modeling, the model that we had developed, right? So what we had done over here was uh, we kind of tried developing the so what we tried doing over here was we tried looking into the accuracy of the model, right? And while we were looking into the accuracy of the model, one of the important thing that we tried doing over here is we tried understanding that that based on the historical, based on the model that we had developed, right? So how is it that the historical figures were looking like? So how is it that the actual versus predicted figures were looking like, and what was the extent of the the inaccuracy in the model, so that you know Okay, so like we had kind of used this estimate, right? So we had kind of used this 2014 till 2014 Q4, and we used that estimated regression equation in getting the prediction, the predicted equations, right? And we had so we had developed this. Now, one thing that we could clearly see from here is, so one thing that could be clearly seen over here is that so there was a kind of a upward and a downward trend happening, and the same kind of a trend appeared in the estimated figures that we had, right? Uh, so the one that we had kind of predicted. Now, yeah, okay. So now, one of the important things that we would like need to do over here again is, one of the things that we would like to do here is we would like to use this model. So that is what we had not done in the last class. So we'll try out from there, right? So for first thing that we'll try doing over here is we will kind of apply this model on the so we'll apply this model on the out of time validation data, so which is 2015 Q2 to 2016 Q4. So this is something that we had not done. So we'll apply this model on that, right? And we'll see how is it that this model, how is it that this prediction actually works on this particular model, right? In this particular case, so it was till 2014 Q4 that we had. So I'll take this out. Okay, so if I the residual is actual minus the predicted values. Okay, so over here what I'll do is I'll take this mean square percentage error. This is the sum of the squared percentage error by okay. So the residual over here was the actual minus the predicted by yeah. So what you get to see is that this is more or less like similar. So in the most recent out of time sample, the predictions are much closer, right? So basically, if in the validation sample or in the out of time validation sample, if I do this, now the question that comes out over here is, this is the out of time validation. So now the question that comes out over here is that one thing that you see over here is that if the T rate has gone down to 0, right? So then the actual predicted value, so whatever you cannot predict, right, is something which is over here. So this is a positive demand over here, but you show it as a negative demand over here. So but there does arise a point when you have this minus 0.08172, and you have but one thing that is very one thing that we have been looking into when we look into this particular regression equation into this validation when we look into this validation once. So one thing that we can clearly see over here is the following, that that there is something which we are kind of missing out, and also that there is a trend in this prediction, right? So there is a kind of a trend, there is kind of a fluctuation, there is a kind of a temporary behavior which we have not really taken care of. So if you have again, like if you have a look over here, you will see that in 2004 2002 Q2 there was a blip. 2003 Q2, not 2004 Q4, there was a blip. 2005 Q4, there was a blip. 2006 Q4 there was a blip. So this blip or this demand has an element of seasonality. Model change. So that will be the first part, or that would be the second part of the regression equation. So what the first thing that we have tried it at a 0 lag. So the second that we'll try it is at a 1 lag. Then what we'll look into is in a transformation of this variable. And another thing that we'll try out over here is we'll try to first stationarize, and then we'll kind of try to develop the model, right? So so these are some of the things that we need to identify. So I'll come to that identification a little later, but before that, what we'll do is we'll try out the second iteration of the model where we will lag the variables by 1. So basically what I am saying is that if the rate of interest has increased today, so let's say from last month this month the increase has gone up, right? So how effective is this from the demand perspective? So the increase in the demand, the interest today should ideally impact the demand for time deposit in the next month. So there must be a lag period. So this is what we want to discuss. So this is what I kind of want to discuss. So over here, we'll start off with 1 lag first, right? So we'll lag the series by 1, right? And then we will kind of look into the other parts. So basically, this is the result of iteration 1. So I'll say rename this as result summary of predictions. So this is your iteration 01. Now when I talk about this iteration 01, what do you see over here? This iteration 01 is a no lag, a simple linear regression model. Right, so it's a simple iteration. So it's a no lag simple regression model, right? The result that we have discussed over here. Now the second iteration over here would be a single lag linear regression model. So the next part that I have is a single lag simple linear regression model. So this is your iteration 2. Right, so when you do this particular iteration, so you have 2 things over here. Again, we'll use the same development data, we use the same vintage. It's just that we lag the values by 1.
Hello. So we are doing single lag just to predict the last value and see the result?
No. What we are doing is what we were saying is that if the interest, let's say the treasury rate increases from 0.9 to 1.1 in 2004 Q2, we'll immediately see a difference in 2004 Q. The increase will be reflected in the next month, will be reflected this month. But now what I am saying is that when there is a fall in the treasury rate, it will take some time for the demand to adjust. So is it possible that there is a lag? There is a lag of a single lag, which can help me express the falling rates with a more accuracy, right? So, so let's say now initially it looks as if there is an instantaneous adjustment, because if you see that as you move from 2002 Q2 to 2002 Q3, right? You see that the treasury rate falls from 1.7% to 1.6%. Now, as that falls, the percentage change in the demand is negative. So there is a fall in the demand for time deposits. Now as it goes down further to 1.3, so there should be another fall, right? So the hundreds of iterations over here. I will just be doing one or two more iterations. One is I will be doing the model iteration 01 with 0 lags, and then I'll do it with 1 lag, right? Then I'll try out a log transformation maybe, and then I'll try out one with the stationarity. So I'll try and I'll check whether these are stationary or not, because the accuracy is the issue, because your system is a linear system, but the actual predicted system has a lot of temporary fluctuations in between. Now, what if those temporary fluctuations are removed from that data, right? So then how does your system look like? So that is the next part that we try to look at, right? So before I try with the single lag simple linear regression model, I think it should be better if we try to stationarize the variables, right? So this is a no lag simple linear regression model without stationarity. So one thing that we can clearly see is that the time series is not really a stationary time series, right? So I'll first try to reset time stationarity, and then we'll try to do it with lags on the stationary model. So what we are trying to see is that if both the time series are kind of stationarity analysis. So what we're trying to see is that if both the time series are converted to stationarity, right? So then it's stationarity criteria. Then how does the model look like? Right? So over here, so first let's try to identify whether the time series is stationary or not, right? So how do we do that? Now there are two ways. So obviously one way is to use the proc ADIMA. We'll use the proc ADIMA with the ADF options, and we'll try to see whether it is, so whether the time series is stationary or not. But before that, what we'll also try to do is, we'll try to see it more graphically, more intuitively, and try to understand that whether the definitions of stationarity is identified in the data. So if that is identified, right? So once that is identified, then we can try to, kind of go ahead with. So then we'll try to, do it more statistically. So we'll pull in all the results. So let's have a quick look into this. So how from the data, by looking into the data, how can I identify that the two variables with which you are working are stationary or not? So now if a variable is a stationary variable, right, then it should always give you, the mean of the variable should be more or less consistent across different subsamples. So what we'll do over here is we will kind of divide the data into different multiple time periods, right? Let's say I have a total quarter. How many quarters? I have a total of 59 quarters, right? So let's say I will divide it into 4 or 5 parts, right? And then what we'll do is we'll compute the average of the groups. So we'll do a simple pivot over here. So for all the variables, that the treasury rate and the dependent variable, we need to look for stationarity, because if you are regressing one stationary variable on the other variable, both the variables have to be stationary. Otherwise, there will be an issue in the final models that we develop. So over here, what we are doing is we are introducing stationarity, right? So before I go in, we'll just include the stationarity analysis. So I'll include the stationarity analysis for so one of them is deposit and T-rate converted. So first what we'll talk about here is graphical analysis. Now, once the graphical analysis is done, then we'll talk about the statistical analysis. Now, the question that comes out here is that why do we need to separately do the graphical analysis when we have the statistical methods through proc arima? So ideally, there should not be anything extra which the graphical analysis actually tells you about. But what it helps you do is it helps you evaluate the data in a graphical manner. So it gives you a more handheld feeling, or it helps you understand the properties of the data more closely, right? So over here what we have is, so I'll use this pivot table over here, right? Guys, just give me a couple of minutes time. I'll just be back and we'll get started. Just give me 2 minutes. Hey, hi guys. Sorry. Okay, so as I was saying, right? So what we'll do is we'll do the pivot. So from the pivot, we'll first try to understand that this is pivot or stationarity. So what we'll try to do over here is we'll just try to understand that how is it that so how is it that graphically we could identify the stationarity of a variable. So over here I have date. Okay, so this is a classic pivot table option that I have over here. And now what we'll do is we'll just kind of group them, right? Let's say we'll group 2003 and 2002 and 3. So this is 2002, 2003. Two thousand four, 2005. 2004, 2005. 2006, 2007. 2008, 2009. 2009. 2010, 2011. 12, 2013. 2014, 2015. 2016. Right. So this is something that you have over here, right? So now over here, what you can see is that there are these mean values, right? So for each of these months, what I have is I have a mean. Now the question that comes out here is that uh, how does this mean look like, right? So how is this? So I'll just do a sum over here. 1, 2, 3, 4, 5, 6, 7. So this is average figure, right? So this is the average. These are these averages, right? So first, let us look into these average values, and let's check how is it that So how does the trend of the thing look like? So these are the averages. This is month. So over here, so now let's kind of convert these first into percentages, right? And then what we'll ideally look into is that how do these means they impact each other. So one thing that we can clearly see is that there was a rising trend on an average from 2002 to 2007, which is pretty obvious, and then a sharp fall in 2008, 2009, and then the average trend of the interest rates have been very different, right? So one thing that you can clearly see is, one thing that I can kind of comment on over here is this time period. If you see, from 7.07%, the mean has fallen down to 1.21%, right? So first of all, there is a structural break that we generally get to see in terms of these variables over here, right? So there is this challenge over here that we have. Now, so that means the question that comes in here is it that this part? Now over here, this part you can clearly see there is an increasing trend on the whole. So if I put it, if I just plot it, I'll get to see this, and this is very steep trend, minus 0.52%, 0.05 to 7.70%. So that change is actually very high, right? So over here, one thing that we can clearly say is that this is absolutely very volatile in nature. And it is this volatility which is, so it is this extreme swing that you have over here from 0.05% to 7.70%, and then again a fall back to 1.21%. So this extreme swing that we have over here is something which is kind of preventing your model accuracy. The causality is absolutely significant and there is no problem, and that's why your linear regression results were correct. But when you are looking into the accuracy, you are seeing that at cases it is totally getting under predicted, or it is always unable to capture something or the other because there was a huge change in the trend, right? So from 2000 to 2007, the average was around a 7.70%, right? So if you actually club that group till 2007 and from 2008-9 onwards to 2014 2016, you will see that yes, there was a tremendous fall, right? So there are smaller ups and downs, but there is a huge extreme swing in this period, and it is this swinging in this period, 2006 to 2013, these 6-7 years, which is actually kind of not getting predicted in the model that you have, right? So your model to some extent is either actually over predicting or it is under predicting. It cannot actually capture that swing. So first of all, what we need to do is we need to go ahead and we need to break this. So what I feel essentially is that there is a very strong structural break in the mean returns, so in the the mean deposits, and that is because of a structural break in the time deposit variable, right? So let's kind of put it here one step down. So this is the PRTD mean series, the PRTD mean series that I have over here. So let's kind of plot this graph. And before I go with this plot, what we'll do is we'll also look into the the T rate, or the T rate converted. So this is the treasury rate mean series. Right, so over here, if you have a look, so again you see that the series over here, the average series has increased. So now observe this part. So the rate of interest has increased from these to these, but on an average between 2004-5 for those 8 quarters, there has been a decline in the demand for that. There was on an average there was a decline, right? Now when this goes up to 4.54, yes, but once again you see that the average trend, when if you look in 2008 2009 and you look into this 2008 2009, you will see that the rate of interest has again gone down. It has fallen terribly from 4.54 to 0.78 and then has continued in this domain, in this rate, right? So what you see is that there has been a certain fall from 7.07% change to 1.21% in the demand for this time series. I mean demand for the time deposits. So between these two trends, one thing is pretty clear, that 2000 in the year 2008 2009, so after 2008 2009, there has been a terrible break in the time series, right? So the overall pattern of the time series had changed from that time period. So if I plot it from 2006 2007, and then if I plot a second time series on this, you will see that there is a stark difference, right? So now the next thing that we'll do is we'll plot these two series, because what I'm trying to identify is the probability or the possibility of a structural break in the existing time series. So is this explanation clear to you? Now, why didn't I go directly to the, what should I say, directly to the proc ARIMA function, and why is it that I'm going via the graphical analysis approach? So is this part clear to you? Because if this was the thing, you would not have been able to identify through the ADF. For ADF, the entire series would have been a non-stationary series, but it is well possible that that non-stationarity is being captured because of one single point, because of one single massive change, and you have 2008 2009 in here, and that is the reason why this particular time period is the one which is creating this challenge, right? Okay, so let's just plot the graphs first. Change, percent change, time deposits. One. Treasury rates. Time deposits underscore 2. So this is percentage change, time deposit 2. So, treasury rates underscore 2. Treasury rate underscore 2 is this. Okay. So you have the months over here. So trend of means for PRTD and T rate. Right, so this is how your so this is ideally how your graph would be kind of looking like. So over here, if you have a change, so if you have a look into this, right? So from 2007, if you have a look into this change, this is kind of spiking up. But after that, if you look into this trend, into this particular trend from 2008-9, you will see that there has been a total crush, right? So this has kind of crashed down from here right to 1.27, and then this the trend in this part and the trend in this part are two different trends, and there has been a permanent change in the trend. Now, given that there has been a permanent change in the trend, we can say that yes, there is a structural break, and it is not only for this this series, right? But so if you have a look into this part, so it's not only about this averages of this PRTD. One onwards, what we'll have is we'll have this particular thing, right? So that is one part that we need to perform over here. So it is about breaking this data set, and then we need to develop the regression models on them, right? So this now becomes our second iteration. So the conclusions from the analysis above is as follows. So observation from the analysis. So there is a permanent change. So there is a permanent change in the trend of the variable. There is a permanent change in the trend and the treasury rate variable. And the treasury rate variable. So treasury rate variable outcome, this is called a structural break. Structural break. In the two sub time intervals. Right? So the third point that we have over here is, hence we propose to develop two zero lags linear regression model for the two segments. Number one is the post financial crisis segment. So this is how these two will be divided, and for each of these two, what we will try to do is develop right. So these are the two segments that we will have, that we would be kind of constructing. So what are the two segments that we are constructing? So one of the segment is the pre-financial crisis segment, and number two is the post-financial crisis segment. Right. So how do we develop these two parts? So the data requirements will now be changing under this segmented model. So the data sample This is 2002 is 2002 till 2006 Q4 will be one of the months, right? So this is the development data. So similarly, I'll do a Control C, Control V. So this will be the out of time validation data. Validation data. One to 2007 Q4. So this is for the pre-financial crisis segment. The pre-financial crisis segment. Right. The second part that I have over here is the post-financial crisis segment. So this will be coming from your 2008 Q1 till 14 Q4. Till this will go on to 20. And over here we'll have 2015 Q1 till 2016 Q4. Yeah, so one challenge is that the relative time period that I have for the first model is relatively lower. Hence, we have just kept like that I have sample, but for the next it's large. So the time span So will you guys be able to do it for me for before tomorrow's session? The initial codes, divide the data into pre-financial, post-financial crisis, and then just for each of them, run the linear regression model, put them in an Excel sheet, and share out the results with me. So that way you'll also have a practice, right? So, and when the results come in, you have the interpretations given over here, right? So, or what you can also do is you can kind of look into how your results have been looking like, and how is it that you would and do you think that there are any issues with the results that have kind of come up? So that can be done as well for you. That is something. Okay. So there are these things you can just because all the results and the explanations are written. But one thing is that the results that we got to see over here, you know, for so in the first model is because the causality between these two is very strong, and that's why that's what the linear regression model has shown. But because of the segmentation issue,
Linear regression cannot capture when there is a structural break or some, extreme value.
yeah. So basically, whenever there is a structural break, it is not only about any linear regression model. Even if you have a non-linear model, let's say you have a time series model as well. Even time series models cannot predict, right, or a structural in a presence of a structural break, because before the structural break, the characteristic of a data is a type. After the structural break, it totally changes its nature. So there has to be two separate segments. So they become two separate kind of behavior, and that's why what I'm looking in what I was checking over here, Deepak, was that is the trend changed permanently? If there is a permanent change in the trend, then you don't, then the historical data before that change of trend will reduce the predictability the model, right?
I have a question that after the structural break, the orange line is almost constant. Okay, so then also linear regression is not good.
No. It's not constant at all. It's not constant at all. So the orange line is which one? Your average rate, right? Interest rate -4% to 8%. Now, if you change your scale accordingly, you can capture this variance, just an impact of the scale, but the values are nowhere near being constant.
One last question. If there is a every 3 months or every 6, then there is
structural base cannot occur every 3 months or 6 months. They are a one-time event, and they are very rare because if something happens at a period of 3 months, 6 months, then it's a seasonal change. It's not a structural change.
So time series can be employed for seasonal changes.
Yeah. So then you need to deseasonalize that period and then back to seasonal. So that's element. So or the seasonal element. So that's a separate class of models. So we are not going to do that. We are just exploring the application of linear regression. But using linear regression, how is PPNR model built up? And this is exactly the way. So you know the iteration that I'm following over here is would exactly be the kind of pattern of like would that be their actual trial and error method that is followed in the development model. So it's essentially it's a linear regression based model, and it will be in this way.
Okay.
Right? So I'm sending these documents to you guys. So develop the model, right? Send it to me before the class tomorrow. I just have a look and then we'll discuss how. Thank you.